For what we will be looking into will be polynomials. And now, for what we have in the case of polynomials, okay, I'm going to come up with what looks like a theoretical expression. This could look alien at first, but once we start looking into the applications, I think the picture will become much clearer. Okay, so we have an expression. So we have a of n, x to the n, plus a of n minus 1 times x to the n minus 1 and for what I have subscripted for a and superscripted for x, you have going down one at a time. And we have plus, and say we just get this down to a of 1, x to the first, and we have plus a naught. And this expression is going to be a polynomial if two conditions are met. First condition is going to be if the coefficients that you have are real numbers. Again, the coefficients had to be all real numbers. And second, for the exponents, in other words, the powers of x, we have to the n minus 1, n minus 2, and so on, are all whole numbers. And what I mean by whole numbers, for the set of whole numbers, those will be counting numbers beginning with 0. Now, in terms of distinguishing between what is a polynomial and what is not, and we'll say for the first instance, we have 3x cubed plus 2x squared plus 5. Okay. Now for the coefficients, we have 3, 2, and 5. All of these are real numbers. For the degrees of x, you have 3, 2, and 0, since we do not have an x term. Okay, and since both conditions are met, this cubic expression is a polynomial. And let's say we have for a second case, we have x to the 5th plus 3x cubed plus the square root of -7. Now in this one, okay, now for what we have in x, okay, now we have integer exponents. But for the coefficients, we've got 1 for x to the 5th, 3 for x cubed. So far we have real numbers. However, in the real number system, we cannot have an even root of a negative number. And because we had the square root of -7, this expression fails to qualify as a polynomial. Now let's say we have, for a third case, let's say we have 5 x to the 4th plus pi x cubed plus 17x squared. And in this one, okay, so we have for the coefficients, 5 is a real number. Now pi, not an integer value, but it's an irrational number that is in the family of real numbers. So pi is real, 17 is real, and the powers of which we have x to be raised, all of these are whole numbers. So both conditions for the expression to be a polynomial are met. So that is a polynomial. And let's say that for, add a case here. Say we have the square root of 7 x to the 9th plus 19 x to the 4th minus the square root of 22 times x. Okay, square root of 7, 19, and the square root of 22. Okay, all of these are real numbers. And for the powers of x, we have 1, 4, and 9. All of those are whole numbers. So the fourth example is a case of a polynomial. And let's say if we have an expression, and we'll say we have 3x cubed plus 2x squared plus 5 times x to the -1. Okay. All right, so we have 3, 2, and 5. So on the side of real coefficients, that test is passed. But now for the degrees of which we have x to be raised, we have to the 3rd power, 3 is a whole number. 2nd power, 2 is a whole number. But for -1, it is an integer, but it is not a whole number since the value is negative. And because of this, because of the -1, this is an expression that does not qualify as a polynomial. And let's say that if we have 3x cubed plus 2x squared, and we have plus 5 times the square root of x, and we have a reapplication of a radical, but this time we have it applied for not a number that is real, but for a variable, where we had the square root of x. And I tell you what, since we're looking at the degrees of x as part of the test, if we rewrite this as base x to a power, so we have 3x cubed plus 2x squared. Now, for 5 times the square root of x, square root of x, remember, your index number is at 2, x is to the 1st power, and in the rewrite, square root of x is going to be at x to the 1/2. Now, so far we have, once again, same real coefficients with 3, 2, and 5. And now, all of what we have in x must be such that x is raised to a whole number. X cubed, 3 is a whole number. X squared, 2 is a whole number. X to the 1/2, it is a positive number, but it is a rational number, but not a whole number. And so, once again, just like what we had with the 5th case last term, we have an x, we have raised to a non-whole number. All right. Okay, so again, you have 2 conditions must be met in order for the expression to qualify as a polynomial.